Hello and welcome to our virtual Lunch and Learn this week. Thank you for joining us. Today we're talking about 1694 electronic circuit protection. My name is Rachel Green. I'm the Digital Communications Specialist here at McNaughton-McKay Electric Company. And presenting for us today is Mike Brennan, Systems Engineering Supervisor out of our Madison Heights, Michigan location. Out in the comment section today, ready to answer your questions, are Eric Dixon and Chris Haichu, systems engineers, also out of Madison Heights. We'll also have a Q&A portion at the end of Mike's presentation for him to answer your questions in more depth. As we continue to socially distance, we're happy to be able to host these live sessions here on YouTube, making it possible for you to join us from the comfort and safety of your own homes and offices. We'll be getting started shortly, but we'd like to allow a few minutes for attendees to join us. As you come in, let us know where you're tuning in from in the comment section. I see Jody and John. Thanks for joining us out there. You can view recordings of previous virtual Lunch and Learns on our YouTube channel under the Virtual Lunch and Learn playlist, and we'll be continuing this series every Wednesday at noon, so be sure to join us on your lunch break going forward. For anyone just tuning in, welcome to our virtual Lunch and Learn 1694 electronic circuit protection. Let us know where you're joining from in the comments. We'll be looking for questions as you have them in the comment section as well, while our presenter Mike Brennan discusses what low circuit protection devices are and which ones are utilized today. We have our specialists, Eric Dixon and Chris Haichu, out in the comment section to respond to your questions as we go along. And we'll also have a Q&A segment at the end of Mike's presentation to address some of those questions in more depth and to allow you some time for any follow-up questions you have. Welcome, Manaling. Thanks for joining us today all the way from South Africa. Good to see you. If you'd like to reach out afterwards or if you have further questions for Mike, you can send us an email at that email address on the screen, mcmclive@macamac.com. Be sure to let us know which session you attended so we can direct your questions to the correct presenter, and Mike will reach out to you directly with his responses. All right, it looks like we have quite a number of attendees now, so Mike, I will pass it over to you.
Great, thank you, Rachel. Good afternoon, everybody, and welcome to our discussion today. I want to go over a brief agenda of what we're going to talk a little bit about, and then we'll get into the content. So the key point today is talking about low voltage DC circuit protection. We'll have a discussion over what we're seeing in industry that people are utilizing today. We'll talk about the 1492 SPM Supplemental Protector, a miniature circuit breaker. We'll show some examples of panel space utilization in existing designs. We'll talk about troubleshooting. We'll talk about difficulties with troubleshooting and supplemental protectors. Additionally, we'll talk about the concept of a Class 2 circuit, why they're important, where you'll see them required in certain applications. And then finally, we'll get into the meat of the presentation, talking about low voltage DC electronic circuit protection devices. We'll talk about the different protection devices that are available, what the benefits they offer, the concept of fixed block design, as well as modular designs. We'll show examples of how they can reduce panel space and show how they can simplify troubleshooting and utilization of those devices. So what is the supplemental protector that we typically see in industry today? What that is the 1492 SPM. It is a UL 1077 recognizes supplemental protector. It's used when a branch circuit is already present, branch circuit protection device is already present. The key point is that it can be utilized in AC or DC, low voltage DC applications. So we're talking today about specifically 24 volt circuit protection. That is a small portion of the use of miniature circuit breakers in this case, but we see this often as in applications being utilized. So some of the nice things about the 1492 SPM is some of the accessories that are available for it today. Additionally, there is available an aux contact, so you can get trip status or on-off status back to a PLC specifically for that branch or that supplemental circuit. There's a shunt trip that's available. So if you wanted to remote trip specifically that circuit, you could do that. And additionally, there's a lockout device that's available. For simplification of wiring, there's a bus bar that can be used along the top of the supplemental protectors. And what that would allow you to do is just run larger gauge wire and feed a bunch of different supplemental circuits. So here's an example of 11 different circuits utilizing an application. We can look at the overall dimensions of those circuits and then look at some additional wiring that would be caused if the requirement is to get individual circuits back to a PLC. So the supplemental protector would then require an additional device, an additional accessory to provide an input back to the PLC. So that's additional hard wiring, and it's also additional space that would be used in the panel. We'll talk about a little bit later with electronic circuit protection how that would not necessarily be required. So for 11 circuits, when we look at the overall dimensions, you're looking at about 271 millimeters. So it's small by comparison, but much larger than what you would see in a typical modular electronic circuit protection application. So troubleshooting. So one of the advantages of the SPM is it's available in a wide range of circuit breaker sizes. It's available up to 63 amps. And what we will often see is our customers using a little bit larger circuit breakers with large DC schematics or DC circuits. What you have to realize is the more supplemental protectors you use, the easier the system would be to troubleshoot. Because each one of those circuits, the smaller that they are, the smaller number of devices that you have to troubleshoot. There's smaller number of devices that you have to troubleshoot for that specific circuit if there was a fault, whether that fault be a short or whether it be just a failure in terms of a device. Often we'll see proximity switches that get crushed that cause shorts in DC schematics. If you have a very large circuit that feeds quite a few number of sensors, then this can be very difficult to actually go through and individually troubleshoot. One of the things to remember is branch circuit protection is required, but supplemental protection is often utilized to protect the wire gauge that's below it. So it's very important that we do this, that we include supplemental protectors. We have seen applications where customers have forgotten supplemental protectors, and they actually had a short in one of their end devices, and it required, it actually burned up some wire, specifically in a conduit, and ended up destroying thousands of dollars in electronics in an enclosure. So they lost the PLC, they lost I/O, Ethernet switches, and power supplies. So it's very important that we make sure that supplemental protectors are included. Again, as we discussed, the SPM does offer aux signaling and contact as an option, but these features aren't built in. And the visual indication, while there, is somewhat difficult to interpret because it's just a plastic presence or not. So we'll talk about with electronic circuit protection what's available in that. So one of the things that we've seen customers struggle to understand is NEC Class 2. So there are products that exist out there today that you're probably using that state on them that they require a Class 2 circuit. Now, a Class 2, an NFPA set special requirements for low voltage circuits, and they're required to as Class 2 circuits. And what that allows you to do is to eliminate electrical shock and eliminate the fire hazard associated to it. But what that does is it limits the overall voltage that's available as well as the amount of current that's available. So you'll see Class 2 power supplies are limited to 100 VA. Now, many of the 1606 power supplies from Rockwell Automation are Class 2 rated, okay, but not all 4 amp and below power supplies, 1606 power supplies, are Class 2 supplies. So one of the things that's very important to know is if you have a requirement for a Class 2 circuit, that you purchase a Class 2 power supply, and it will be labeled on the individual product. UL has very specific tests that include additional circuit protection for those individual devices. So how do I determine if I need a Class 2 circuit? So here's an example of 3 sensors that exist today. These sensors are, some of them are laser measurement, some of them are color measurement, but you'll note specifically on the side of the sensor the requirement for a Class 2 source. We're seeing this more and more as our sensors become more and more complex and offer more and more features that there is the NEC requirement for them. Now, these sensors are specific to Allen Bradley, but all manufacturers that we're seeing across the board for their high-end sensors are beginning to require Class 2 sources. So what do we see? I want to ask the question, do you use Class 2 power supplies today? Do you know if you do? They would be labeled as such, and just remember there's additional testing and circuit protection that's being done. Are you using 1492 SPM to limit supplemental protectors to limit the circuit to less than 4 amps? What we've seen, and I've seen this a lot over the years, is that folks know they need to limit and use a Class 2 circuit, but they'll use a supplemental protector to do that because there really prior wasn't a very easy method to do this. You'd have to have an individual Class 2 supply for each one, and that can end up being a little bit cost prohibitive. So having multiple SPMs is easier to troubleshoot because the DC circuits are smaller, but this does not meet the Class 2 circuit requirement. So the different methods that you would use to meet that Class 2 requirement would be specific 1606 power supplies that are rated as such. And then Rockwell Automation offers 2 different products. There's the 1692 electronic circuit protection as well as the 1694 modular electronic circuit protection devices. And we'll have a quick discussion on those products and what they are as well. So let's think of them in 2 different flavors. There's a block style and then a modular style. So the 1692 electronic circuit protector is the block style device. And what that allows you to do is run one higher current 24 volt input into the block and have multiple outputs. When you look at the example on the slide, you'll see that that has an input and then 4 10 amp circuits that are outputs off of that individual block. So obviously this isn't a Class 2 specific circuit protector, and we'll show you an example. There is a block style that limits you to under 100 VA for each of the 4 outputs. We'll talk about that in a second. So one of the things that this block style does offer for you is there's already a hardwired input that you can wire directly back to the PLC if there's a fault on each one of these circuits. Additionally, you'll notice that there's an LED for each of the output. So what that does for you is if there was a fault, you'll know by LED which branch of that circuit has faulted. You'll know where there's a short. You'll know if there's an individual issue. Additionally, there's a reset button that you can press on the unit if you've had a fault and you want to test to make sure the fault is cleared. So this unit's only 45 millimeters. So if you thought about our previous device where we had 11 circuits and it was 271 millimeters, 2 of these would give you 8 circuits, and that would only be 90 millimeters in width. So we could utilize the block style and have more circuit capability. We'd have better enunciation, fault diagnostics without additional components back to the PLC, and we'd have a smaller space. So you can see where the block would make a lot of sense. Now, here's an example of the different numbers that are available and the different current ratings or output ratings that are available. Now, you'll see that they're available up to 12 amps with outputs, but additionally, there is one Class 2 part number that gives you 400 VA max per circuit, Class 2 specific device. So again, like we discussed, there's LED enunciation, there's an OK input diagnostic that can go back to the PLC. And additionally, what I might not have discussed is that you can even control the outputs directly from the PLC. So what is the difference between a block design and a modular design? Well, on the left, the 1692 that we were talking about, that's the block design. On the right is a brand new 1694 product, which is a modular design. And what this allows for us, we'll talk a little bit about. So what is the 1694? So again, this is specific to 24-volt DC applications. So the 1694 it's a DIN rail mount electronic circuit protector that allows you to choose the number of circuits that you want to use. Okay, and what we'll look at is there's a ton of diagnostics in these products, and there's a ton of modularity that's available. So it's easy. It allows you to add circuits quickly. It's a MOSFET design, so the accuracy of the tripping is much better than that of a miniature circuit breaker. So, and additionally, you can very quickly understand whether or not you're overloaded to the individual circuits as well. So here's an example of the diagnostics. So when you look at each of the loads, if the loads are connected and turned on, then you'll see a green light. When you've reached 90% of the load capability of the output, and you'll see each one of the outputs are labeled based on current, you'll start to get a flashing green amber LED. But one of the things that we've talked with customers about that they've struggled with, if they have multiple power supplies in a specific application, how do they know which power supplies are loaded? What are they loaded to? In this case, you can visually look at when you've reached 90% of load on a specific individual output. One of the things that you'll notice in the lower left is one of the outputs has gone dark. So each one of those LEDs is also a button that you can push. Now that button will individually turn that circuit, that specific circuit off. So you can manually switch the circuit on and off by pushing that LED. So that's very nice for troubleshooting. Now again, that doesn't preclude lockout tagout. So we shouldn't use that in an application to go in and do individual diagnostics or checking. We want to make sure that we follow all safety rules, but it does allow you to easily switch off. If you're in the testing phase, you can individually switch off a circuit. Now, if you have an overload or a short circuit, what you'll notice, and in the lower right, you'll notice one of the circuits is red. So that'll tell you if that specific circuit has a short or has an issue. So what makes up the 1694? Well, there's three different types of modules. So there's the power feed modules, and those are available for power as well as common or ground in this discussion. And each one of those power feed modules has an auxiliary contact built into it. So there's a left hand, a center, and a right hand version of each of the power feeds. And again, they're push-in style terminals. The protection modules, those are available in different current ratings between 1 and 10 amps, and you can have either one circuit or two circuits for each of the same housing. So if we were looking at, again, our previous application where we had 11 circuits, I could have one power feed module, I could have 6, call it 4 amp each outputs, and then have my common as well. So I'm reducing the overall number of terminals that I'm using, and I'm also additionally making it easier to distribute 24 volts. I'm going to have diagnostics. I'm going to know when I've reached 90% of my circuit load. I'm going to know if there's an individual fault, and I'm going to be able to easily and quickly turn off individual circuits if I need to do any sort of testing. So here's an example of an application as it's put together. This specific application has 5 circuits. So in a 10 or 11 circuit application, it could be just a little bit bigger than this. And you can see we've got power feed modules as well as the individual protection modules that as they are defined. And this gives us the ability then to route between different panels. So we can have one up to 40 amp supply, and we can provide individual circuit protection as well as class 2 protection where required. So in summary, what we've seen is a lot of folks have used the SPM for low voltage supplemental protection for years. And these units the SPM is really flexible. You can use it with AC/DC. You can use it up between 1 and 63 amps, so it has a really high long current range. they can take up more panel space because by comparison, they do have much more terminations. They're a little bit more difficult to troubleshoot, and they do not support Class 2 designs. So one of the things that you want to take a look at is some of the sensors that you're using, some of the safety devices that you're using to make sure that they don't require Class 2. And if they do, applications like this can make it easy for you to be able to implement. So understand if you do see a requirement for a Class 2 circuit design, it can be achieved specifically with 1606 power supplies or these electronic circuit protection devices. The electronic circuit protection devices that we have offer a lot of flexibility because we can provide just an individual specific block with 1 input and 4 outputs, or we can supply a modular format that has 1 input, and then we can select the current ranges that are outputs or Class 2 protection that's required. We have visible LED diagnostics, and I can quickly turn on and off circuits. And again, your designs can be future-proof because more and more devices that we're seeing come out have Class 2 requirements. So, quick presentation today. Rachel, I wanted to pass it off to you, and we can take a look at any questions that are available.
Yes, thank you, Mike. We don't have any live questions at this time, but I'd like to go ahead and give a moment for anyone that has any follow-up questions. While we wait to see if anyone does have any questions for us, I just want to remind you that you can always send in any questions you have while you're watching this as a recording or in the future to that macandmaclive@macandmac.com email address there on your screen. And it looks like we do not have any questions at this time, so I'm going to go ahead and thank you, Mike, for this wonderful presentation today. Thank you to Eric and Chris for being our resource out in the comments section. And please join us again live and subscribe to the McNaughton-McKay YouTube channel for more industry content like this. Thank you, everyone, and have a great day.